Botswana has a massive gas potential that has not been developed for a number of reasons. So there's a trick to how to get it out in commercial flow rates. And typically that coal is also in groundwater. So the groundwater prevents the molecules, because the gas is adsorbed to the cold surfaces, not absorbed. It's not inside the coal, it's outside cold surfaces. And any groundwater in there will stop the gas from flowing. Therefore, you have to dewater those coals very carefully at very controlled pressures. If you do it too fast, you collapse the porosity of the coal, the pores of the coal, and the gas won't flow, even though the water is gone. So you remove it at a very controlled pressure. It might take 3, 4, 5, 6 months of dewatering. But as you dewater, the gas comes up with the water, a bit like soda water, and it starts flowing, and progressively there'll be more gas than water, and ultimately there will only be gas. To do that takes a bit of skill, and no two gas fields are identical. So there's always local knowledge that you have to develop. That's what we're doing. And typically when you get a production well, you have a single well and then you're surrounded at say 300, 400, 500 meters. You put 4 other wells around it. So you have a 5-pointer, and they all dewater. They will all bring gas to the surface with the water. But the central one will be your main production well, because that will be the most dewatered. And then you collect that, and you have several clusters, because see, unlike a gas field associated with petroleum, you have numerous small wells instead of one single big well. So you bring all that gas to a single point. There you remove the final bit of water. You remove other impurities that it has. In our case, water is an impurity. Nitrogen is an impurity. Nitrogen, as you probably know, is the most common gas in the atmosphere. So we have about 7 or 8% nitrogen. Then we have a trace of CO2, I think 0.2 or 0.3%, which is very small for the gas. We have to remove that, because if you turning the gas into liquid, then that CO2 forms dry ice and it blocks your tubing and causes a mechanical problem. That's a very simple process. You just drop the temperature to minus 162 degrees centigrade. So you don't use any chemicals or anything like this. You just use pressure to reduce it to that temperature, and then it's liquid.